On Thursday, if I'm not mistaken. It's 4:30, no, yes, on Thursday. It's 4:30 at my place, prime time, everywhere it matters, that is when you're watching. Or live or replay. That's prime time. This is a live stream where we build something electronic, something nice, without any product managers, deadlines or whatever. I make it better, I have some coffee. Deliciously freshly brewed. Half an hour ago for setting up everything again for streaming, yes. So let me first check something on YouTube. So YouTube knows that this is not made for kids. That should be something which that you do. Okay, yes, what did we do? Let's change to our Diptrace, our EDA package. Last time we worked on arranging the whole PCB and everything, but it seemed like, oh, that doesn't look correct. That doesn't look correct. Let me change something in the settings here. Let's do this, and now I'm big again, and in just a second I'm small again. Okay, what we did is we've started laying out the power supply section, but we don't want to do it 3 times. So I say we do it only 2 times, and we refactor the whole schematic again. Yes, but it's only a short refactor. We're going to use Diptrace hierarchies to copy the schematic 3 times. And with that hierarchy system we can also change, can also copy the design the later easily, more easily. So we're going to do this. Yes, I need some more coffee. I really thought I could start at 4 o'clock or at least on 4:20. Unfortunately, technical problems came in the way, but that's not a problem. Or we're not going to make it a problem. So we will take this sheet here, and we will, yeah, that looks everything right. And we will do an hierarchy view on that. Edit sheet type. Going to build a hierarchical block out of this. Go to our channel 1. Where's our channel 1 LED driver? Here's our channel 1 LED driver. I'm going to copy our complete channel 1 LED driver. We will add a new sheet. Again, yeah, for some reason we deleted it. Delete now our channel. That's important, we will now delete our channel 1. Make this a hierarchical sheet. Add sheet type hierarchical block. And paste our LED driver again. So, the big thing with hierarchical blocks is that these hierarchical blocks are completely isolated from the whole schematic. So, in this schematic there will be no real ground and no global nets. So we will replace everything to be certain I/O ports. And yeah, let's start. Removing all of the global nets here. So we'll delete it, and we will add an hierarchical I/O. We will work later on the ground. But first of all, do all the nets here. Delete from nets. We will name them directly, that's better. Yeah, I needed to get some. So we will rename that. That will be our voltage. You can write it out, voltage change. No, it doesn't look good. Let's voltage change. So that's our voltage change. Then this here, that was circuit to that was data in, wasn't it? Oh man, I have to look it up. Yeah, I'm working with currently working with AI tools, and it's change mode, and it is quite some tedious installing these tools because always something goes wrong, and it's very frustrating from time to time. Even if you're using these automatic 11111 installer, not so much fun. So that's our voltage change mode. Voltage change mode. Mode change. So here can change the voltage, and here can we change the mode from digital to analog. Okay, that's great. Although let's write that to, like, if you're refactoring again, we can simply add a comment. From analog to WS2812B LED style. Yeah, that's great. I'll certainly like that, and we'll move that a little bit further to the left, because we have all the space in the world. Please go. Yeah, that always happens. You get always some kind of change in the scale for some reason. It simply happens, and if that happens, you always get these steps everywhere in the schematic. That's unfortunate. So okay, we have that. That's great. So yeah, that looks everything great too. Okay. Now we will remove all of these. Delete that. Yeah, from now on I will stream a little bit more often, because I want to get this project finally done. Maybe we didn't get this PCB in production yet, and that's not good. I want to have this ready at some point this year. Maybe start until I want to have a product, physical product prototype ready this year. No, this year, till the end of next month, with all function tested, and yeah, okay. And we'll change these. That will be our blue button, red. So will be LED red, slash ground, LED red underscore ground. Yeah, that's LED red underscore ground. Can we make them a little bit? No, we can't. Yeah, that's okay. Then this will be LED green, correct. Does F10 work? No, it doesn't. Okay. So that's LED green. That here is LED blue slash data. Okay. So we have that change voltage, change I/O. Then we will replace this one. Delete and And this one, this will be voltage plus. Or VDD. Yeah, let's call it VDD. Because effectively we'll get an effectively we'll have an walking schematic that looks like every other part, and oh, that is what's that? That's channel enable. Channel enable. Now we'll replace every single ground with an extra wire. Because when it's isolated, and when it's isolated, we want that. Let me change something on my second screen here to the left, because I want to have some more information. Okay, great. So I won't do anything in bulk here, because one thing I really don't want to risk is having some multiple creating errors during the refactor, and because I don't want to have errors in refactor, because that I already asked a peer of mine to take a look on the schematic, peer review it, just to find idiotic errors that you produce during live streaming. For example, I had an error with my multiplexing. Yes, that happens, but who cares? So that's this one, and next this one here. And because, for example, I can't do math on stream, and if I have someone, and if I calculate something on stream, it goes horribly wrong. Don't worry, I've cut it out because it didn't really look too bad. Yeah, before I'm starting to create errors with simple ground or with ground, I will do everything as separately and by itself on this part. Makes it way easier. It really does. So let's go back to the AI stuff. I mean, if you're using, I was able to get stable diffusion running with no problems, but as soon as I was even able to start some training, but I wanted to use LoRa Dream Booth, because that's something Stormcore uses. Yeah, Stormcore uses that to create his trainings, and it's I was able to get it running. That is ground. For some reason, I'll certainly start working on this again today. But first of all, I need to do something fun, and that's why we are in this stream. Good. That looks great. It even has the identifiers I wanted. And now you can delete those, because we don't need those anymore. No way and away. Delete that. Yes, this one is not blank. I copied the right one, did I? Yes. We want to delete channel 3 also. Delete, yes. Then, before we continue, let's rename this, that's the LED driver. That's power stage, LED, power stage, stage, yes, great. Let's save this as schematic, save it as a schematic too. Let's call it schematic 3. Let's add some more. Let's add some more comments, and we don't need to use acronyms or shortcuts. Change mode from analog to VS. Style, yes. Style LED strip, yeah, that's okay, yeah. Let's add a comment down here too. So in analog mode, RGB signals. In WS2812B mode. The problem is in German, you write every none big, and it's always you get always messed up in English, and you want to write everything capital letter. Yeah. In WS2812B mode, red and blue change to the secondary functions, data and continuous ground. I don't write out continuous, that's not. Let's move that a little bit further to the right, like this. You can move that a little bit to the right, that's good. Yeah, now you have some more space to comment here. Because I certainly know if somebody looks at that in a year and nobody wants to view 20 live streams, 40 live streams of somebody building something. So I will write it out a little bit. Maybe someone else will have fun with that project. I'm sure somebody else will have fun with that project. Okay. From analog to style LT strip. If that's low. So let's think about it. So if that's low, it shouldn't conduct, right? Yes, it's yeah, of course. If that's low, that will not conduct. So 0 is 0 double is analog, and 1 is VS. It's VS WS2812B. Oh, great. And then add a comment here too. That of course doesn't look that great. Move this one a bit to the left, like this. So now that this looks now way better. Change voltage. Change voltage. Between 5 and 12 volts through feedback network. Through the feedback network of U1. I think it's U1, right? Let's check that. Through a feedback network of U1, yes, that's correct, TPS. So 0 is, let's think about it. If it is 0, so we don't conduct it, we have an higher voltage, and if we have a higher voltage, that results in a higher output voltage. I would say 0 is 12 volts and 1 is 5 volts. That should be it. Yes, if the voltage drops, the voltage of the output will get higher. Wait a minute. So it's an error amplifier, and if we have an error amplifier, okay, I will have to pause the stream for a minute. I will be back in a second. I will be back in a second. Where is my... Here, black.
Let the beat rock. Let the beat rock.
Okay, oh I have audio again. Hello. So let's get some fresh air in here and continue. So we have a new viewer. Hello. You just arrived when I've noticed that I have my audio turned off. Okay. Now, this left side here is now cramped a little bit to the left. That gives us some space to have these out here. Maybe move them a little bit more to the side, because we still need to get... I don't think we'll use this hole here. We still need to get a lot of space to the left. We still need to get this circuit 3 times in here. So that's okay. Oh yeah. And maybe I should change. Maybe I should change that too. So the circuit is now cramped in here. And set enough space for these 3 wires. I do hope so. This can be routed up here. This can be... that could be enough. Okay, first of all, don't bother me with top silk. It's not that important. Okay, what's this? Is the... Oh, okay, this is an... this is the pull-up resistor. Can be placed directly in here. Like that. Good. So, now we have everything set up. We can... Is that somehow important? I don't think so. This one here. Can make those a little bit slimmer. And move them a little bit further together. Okay, that looks good now. No, that looks good. While we're in it, I'll do one thing. I will add an... Okay, now it's only important if you want to use the under voltage lockout. Okay, we could keep that. So, that looks good again. So now we can start adding the ground fill again. First of all, let's check if that is that works. Let's go to hierarchy. Is there anything that we've missed? What's that? No, that's part of the power supply for the Pico. And let's see if we can already copy the placement correctly. That was tools, root, hierarchy. And here we can take block 1, select blocks, and I can't do it yet, so we need to route this first. But if we take the size of that, we should get 3 of these in here. So that looks good, and yeah, let's start. So first of all, check again. Get some coffee. Okay, I'll do a quick break. I'm back really fast again. Or I'm away for a minute or so, for 3 minutes. let's continue again. Let's continue further, not again. So now it should be. Actually, what we could do is we can move that to the side more, because we will need to route all of these wires, all of these vias through here, and that's way more easier if we have some space. Okay, great. Let's start routing everything. Very fortunately, that is routed already, and okay, we will start with those relatively thick traces. Go down here. We'll directly give it lots of space. So these we want to have directly in here. Good. If you want to make them as you want to make this trace, want to have some space down here, so we are still able to move everything or get all the traces from this side down here. That's important. Then let's continue with 3 millimeters, 0.3, to have something which is in quote marks big enough or small enough, but still manufacturable with, oh, that's all ground, so we don't want to move that. But okay, oh yeah, let's do this ground trace here first. So this trace will carry 3 amps, so we want to have this as relatively thick. So we will do a pour that goes like this. This and this. And this. Let's start simply by doing something. So we have already calculated the right size of pour and trace last time. I think it was 1.5 millimeters. Of course, we don't want too much voltage drop around this part here. We'll simply start like that. We can connect it later. Okay, that's good. So we can have that move around here and there. And like this. And like this. First of all, I was on wrong height. Yes, they are. Good. Let's change the distance before we do too much here. And that's bad properties. It's properties. Where are the properties? Yeah, I have properties. X is 200. Let's say 220. Let's make this properties. Properties, that should be then 240 to 24. Okay. And that is allowed to be then 28. Properties, that should be 28. So that's evenly spaced and looks better. 28, okay. And that's properties. Properties, that should be. Let's make this 15. So there's quite a noticeable distinction. And add that stop here. Like this, okay. Because then we can still use, yeah, we'll move this guy here. Because then you can still use this part here for power dissipation, and have as much space as possible to get all the heat out of the little converter. Yeah. So simply say that all here is our. Although most of the heat will get dissipated in this area here. Yeah. Pad properties. What kind of net is that? Net properties, that's net 2. So we want to connect this here directly to properties. Use net clearance, okay. We'll check why this doesn't work later, or we can simply move it up a little bit. That's good too. So then we get here new net. Properties, connectivity, want to have that connected to net 2. Okay. And update. You want to have some sort of properties. Have a little bit more clearance. Connectivity, we want height net nuts, thermals, 2-spoke 90 degrees. And update. Okay, why isn't it connected? Let's say only 2-spoke. Ah, okay. An update, please update. Let's do this manually. And this can be really fat trace. 1 mil. Oh, 1.5. Oh, we don't want to move this one. Okay, great. Ah, no. So that's good. So we can get most of the heat out of there. I think that's quite substantial. That's quite substantial to get some heat out, yes. We still have some space here. Maybe you can extend this plate a little bit further later. That's good. And then continue here. Okay. So make it a little bit more straight. Okay. So let's check that. Properties. Yeah, before we fiddle around here, we'll make a recourse grid. So. Now it should be easier to get it somehow straight. Oh, that does look acceptable. Give this a little bit of place here and here. So let's pour that please. Update. Yeah, that doesn't make so much sense. I would rather use that space here for more heat dissipation for that area. Good. That's great. Let's continue down here. And let's do a pour here too. Because that will be the pour connecting the positive supply. And also providing some heat dissipation. Which is really important in this case. So what net is that? So that's net. That is net VCC. So we connect this to VCC. Properties. Connectivity, connect to net. VCC. No, that's a problem. That's a real problem because if we connect that to VCC, that means no, here's no reference to VCC anymore. That's good. Is that simply called VCC? How's that net code here? Net 131. Why is it here VCC? Net name. Because if that's connected to everything else, is it? Do we have a reference to other parts? It goes up here. That is not good at all. We need to investigate that. Simply save that again. That's schematic free. Reload it again. Renewed by schematics. And now this is not connected anymore. Great. Or is it? Okay, let's wire this up again. After we have wired this up, we can... What kind of net is it now? It is connect to net. One, three, one. Properties net 131, and is net 131 available here? Is that net 131 in the same room? Is it? I do hope so. I do hope. But it doesn't look like that. So that net is not in the same room with us. That's unfortunate, and that's not very good. It's not good at all. First of all, let it slide. Most probably it is referenced because we have connected it on the higher hierarchy layer, or in the higher hierarchical layer of the schematics. So it could be that we're good, maybe. So let's try it out. Let's simply try it out and see what happens. We want to have that spokes, of course. Bordering connectivity, we want to have spokes. Okay, great. That looks good. This one we will add manually. Yeah, great. So update. Great, so that should be enough heat dissipation for that little fella here. And yeah, so what kind of net is that? That is channel out 1 default. So let's connect this to properties. Channel out 1 default. Okay, please. And update. And we want to connect it via spokes. Properties. Connectivity via 2 spokes. 2 spokes. That should be good for this one. Yeah, that's great for this one. Looks like not quite okay for here for some reason. Let's give it more space to give it a little more. Oh, I don't want to move this. Lock it. Lock it. Why is there not the? Yes. Nope. Oh, come on. Yeah, because I've so now lock it. Thank you. Great. For some reason it does not get connected, and that's unfortunate. Let's give it a really big fat trace to connect to, and then everything should be fine. Of course, while designing that inductor and everything, I need to start thinking about connecting, calculating those. I couldn't stop. Okay, well, that's good. That's good. That needs some connection. So we'll give it a connection here. For some reason the spokes don't work, but that's not a problem. Let's still a fat trace. Okay. It's connected with what? For some reason Diptrace doesn't realize that this is one of the same trace, but yeah, I guess so. In the end we will pull up the ground further. So we have lots and lots and lots of heat dissipation. Actually, I'm not sure if we want that, because if we don't have this kind of... Yeah, but let's start routing for the rest. We still need to do that too. Okay. That can be go through as far around as possible. So I don't want to go too much under the fat traces to reduce coupling. Oh, it was a Game Boy one. Nice. So these two get connected. That can be done. This can be done here. Yes. Let's connect further. So this one is connected here too. This one I suppose, no, that one is not connected. Let's build some nice big way around. Great. Oh no, I don't have. Oh, that's not something I want to play, because I don't have the rights for that. I don't have the rights for that. Hopefully nobody will notice. Or maybe someone will, but I don't care so much. So. Because it's not monetized either way, so I don't care so much about it. But I want to have my copyright as clean as possible. Either way, because that's good practice. Always mention the artist, because not mentioning the artist is a little bit meh. No way. Not good practice at all. So let's connect this here. Okay. That's this complete circuit, and so this needs to go there, there, and there. Where does this go? Okay, no, that's correct. So let's continue this pattern and go around in big circles, because I want to keep as much space as possible for other traces. Okay, then this guy here. This one can go directly. It can go more direct. Oh great, I don't need to. I can. Yeah, we'll go back. We'll go around. Because if I go around, possibility for a fuck up is a little bit smaller, and because I have already connected everything in this area, I can be very can do it without any problems. For this one, I'll do a limited. No, do it more limited, because no, it's not that important anymore, because we have gotten all of our traces, and that's of course great. We get all of our traces back and through, and that's good. So. And let's continue here and here. Here. Come on. Where do we need to go? Oh, that's VCC. Oh, that's our enabled circuit. There's nothing to search up here. Go way down there to the enable pin. Doesn't make any sense to stay up there. So you all go a little bit further up. Yeah, and then now there's no space for more ground. Yeah, but that's okay. I can live with that pretty good. But that's ground too. You can connect this ground here directly. That's VCC. And that can be go directly through here. And get a relatively direct path. You still get at least some ground coupling here, but effectively that makes the circuit slower and reduces, and that will reduce the amount of unwanted behavior a little bit, and that's something I like. So where are these connected? Of course they're connected to this part of the circuit. And this still needs to go to ground. Okay, so we do something differently here. We will add another pour, which will fill this area here. Is there another? Here needs... No, that's all not ground. Okay. Oh, that's all ground too. Yeah, that's of course not very. That's not very efficient. So well, that's important for slow voltage, for low voltage drops too. So that's all ground here, right? That's all ground. Net 2. Properties. Connectivity, net 2, yes, okay. So we will extend this okay, so we'll extend. So we'll extend this ground plane a little bit. Of course, that's exactly the way I've imagined extending it. And we'll extend it up here. And we will insert another point here and another point here. Is there... No, there's no reason of extending it. Is there any reason to extend it on here? I mean, it almost only increases the pain in the abdomen for soldering that, and actually want to keep that small. Want to keep it relatively small. Yes. Let's hydrate. As much as possible, and then throw these away. Almost. Let's insert some points here, and so what we will definitely do is we will insert the ground path up here, having a nice big ground plane. But after that, this will be all for that, because do we have anything here that needs to be connected? Yes. From this point we simply have a really big trace that simply goes up here, and it goes down. Because there's no reason to have some ground plane up here. There is no reason at all. Down here we will have relatively small wires because don't expect to have so big of currents up here. And then we'll port again. Update. Possible D0. Okay. Where's the D0? Where's net 5.1? Then we'll connect this here too. After that, of course, we will add a big ground plane down here for more heat dissipation. Of course, you could start calculating everything, but there's no real point for that yet. Because we have such a massive ground plane, and we don't need to optimize everything so much, because optimizing that would take quite some calculations, and I have certainly not that inclination to do more calculations on that stream. At least not on stream, at least not unprepared. I have no interest in that currently. So let's connect these together, and we have still some space to the left. Now let's connect those like this. And move that to the side, great. We can take this on the Überholspur. Like this, this goes down, down, down. And one of these now needs to go further here and straight to the feedback loop. Yes. This needs to be connected like this, relatively directly. And what's that? That is the... oh, that's the enable pin. That is so uncritical, we put it on. Yeah, that's really uncritical. We have so much space, we put it like here and like this. And give it another go like that. Go down here. Here and so okay, we'll move that around. And we get this here connected to the... okay, that's not better at all. Okay, and let's move that down here, up here, down here and go here through there. And from that we can connect directly. No, we don't want to go over the switching part. That is taboo. So, and let's go up here. And connect that, great. So we now need to somehow connect all of these transistors. Okay. So, and let's continue here. Yeah, we go underground here. That, and then there is another one. There should be one other, yes, that can go like this. These are both grounds, okay. Connect those here. And now this can be moved through here to ground, and it should be great. Up here, and up here. To the side, and we will merge back here and connect to that. Okay. So now I have our transistors connected, we have that connected. Do we have everything connected in here? It was surprisingly pain-free. Oh wait, didn't set anything. Yes. I still need to get this connection up and running. Can I move a little more further to here? Great. So then I just noticed we didn't have, did we check if the design rules are according to JLC? Yeah, great. Let's make some space up here. Move that resistor a little bit to the front. Yeah, we can still move them all, that's good. Oh, we didn't connect it, those yet. Let's do this. Let's connect those. Oh, it should be a relatively thick trace, I remember, so I'll make it a little bit thicker. Okay. Almost saw stream. Great. Yeah, if a 2-hour mark, I will... Nope. I will definitely turn off, because I need to have other things to do too, but I want to get this finished. Okay, that's better. That is better. So now let's continue with that last conundrum, I hope. Oh yeah, I can move that certainly a lot further to the left. I can make that more accessible and connect. Oh, I didn't connect this one here yet. Oh, there's a lot of space to go under. It's not a problem. It doesn't look very good. So, like that. And let's move this like this. And see, can we, first of all, want a very small trace. Move it to the side later. Can certainly move that a little bit more. So we move that first of all to the side, we'll move that more to the side. So we get some space for this little fella. And move it from here to here, up, down to here. I don't want to have this via over there. Okay, now it gets interesting. Maybe we simply say we do a shortcut. Oh yeah, that's a way better idea. Do it like this and this and this. And move it from the side up. Under here, because this trace is not very shouldn't be that. Although it's a really high impedance track, there's 3 mega ohms up there. Not a good idea. We'll move this pore a little bit to the side. Oh yes, you certainly move that port to the side. Oh, then I just realized. Oh, that's okay. I do have some notifications here. Okay. Nope. Yeah, I will certainly move that port to the side because that doesn't happen here at all. And make some space. Give me some space. So now we have managed to create some space without having compromised so much on the thermals. Or maybe a little, but that should be still acceptable. That should be acceptable still. So now we can move this a little bit up. And remove that trace. And route it again. We'll delete that segment, unroot segment, and unroot that segment. Because I really don't want to have, traces going under the main body of the chip. Because there's lots of switching, lots of bad stuff happening in this device. And with high current and with high inductance in here and everything, and I don't want that at all. Not at all. Okay. I don't want to have that at all. So simply remove this to the side. And go down under here and go back up here. Nope, not like this. That's interesting. That's interesting. Yeah, no thanks. Let's hope that these are only 2. Yeah, don't risk that. I don't want to have that zombie trace in plus infinity and plus infinity. So we go back here, up and suck. Okay. Yeah, I want to have as little coupling as possible. So I have some space here, that's good. And continue with that. So this goes down here. And here, and now I realize I did all of this for nothing. Great. So my attention is almost at 0. And no, that's a sign. I may be able to finish that today, no? Yeah, I will try to finish that today. Oh, I should finish this today. At least this one part here. Okay, I'll move that a little bit to the side. And move that also a little bit to the sides, like that, like so, like so, like so, and like so here. And no, I can't move that. Okay. I still want to keep it as compact as possible. So let's move this a little bit more to the side. There's plenty of space. We can change this one and unroot that segment. Yeah, now we get into the part where every millimeter, every little thing is important. So, and now we can go inside here. Can bury this trace underground under the segment. Like so. Like so. Here. Like so, like so, like so. Okay. Put it to the side, like this and like this. And now this can go to this without any problems and without even needing another layer. Okay. Yeah, next time I will definitely check the design rules again if they are connected correct, if they are set up correctly. That does look okay. So let's check if you can add some. Let's check if we're able to add some. Can we add some? Now can we do the hierarchy stuff? Can we do that? Verification library root hierarchy. Oh yeah, no, it's place as root. So select block, copy placing and routing, and now we have a second almost place on okay. Okay. So this one, this copy placement and routing, okay. And now if that block itself is great and we added the next via, we can simply put 2 more of those in here and then everything is fine. Almost. But yeah, we get the point. And I have 2 more of these. The design is effectively ready. So most likely I will be streaming tomorrow morning again. Finish that design for 80%, then do another 80%, and then we should be able to send it to the front plates, and then it's ready for manufacturing. Great. Good. Thank you so much, and see you next time.